Good morning, good afternoon. I've pushed the start recording, so let's get started today. My name's Scott Lindstrom with SIMS. This is the continuing webinar series, the FDTD Satellite Applications webinar. Today's title is Analysis of 2 Lake-Enhanced Snow Events Along the Tennessee River. Our presenter today is Matt Anderson from the Forecast Office in Huntsville, Alabama. Can we go to the next slide, please? This is a series of, let's call them satellite chats, where forecasters talk about how they may use satellite imagery in the forecast process. We are always looking for speakers, so if you want to volunteer yourself or someone else, please contact either me, Scott Lindstrom at NOAA.gov, or Dan Bykos, who's at CIRA, but also has a NOAA.gov address. And there's a website too with all the past talks too. Go to the next slide. Just some protocol, about 20 minutes for the speaker. Send questions via GoToChat or ask during the Q&A period by phone at the end. This should be about 30 minutes long in total, with 20 minutes for the speaker, and we should be done around 18:30 UTC. Don't press hold and mute yourself. Take it away, Matt. Thanks.
All right, good morning or good afternoon, everyone. I believe you can hear me and see my screen, so I won't have to verify that. But anyway, Scott had seen my presentation at NWA about 2 lake-enhanced snow events along the Tennessee River, and I actually didn't have any satellite data in that talk, but mentioned in the conclusions that I wanted to look more at the satellite data and stuff like that. So I said, if you want to go ahead and do that, how about you present here at on the satellite webinar? So here I am. I did this research, looked a little bit with Tim Coleman, a research scientist here at the University of Alabama in Huntsville. We looked at a couple of these events and kind of take it away here. So with lake effect snow, I'm in the office here in Huntsville, Alabama, so really not too experienced like some of you that may be listening from Great Lakes offices. Really haven't even worked at any of those offices kind of much further north than here, so you know, haven't really seen snow a whole lot, many snow events throughout my career, but seen a few. But anyway, there have been numerous studies, as you know. There are fewer studies over smaller bodies of water. The Laird et al. Studies, I believe, are both over the Finger Lakes region of upstate New York, so nothing near as far south as Huntsville, Alabama. But as some of those lake effect snow offices know, I'll go into this for some of the others. There are several factors that must combine to produce these lake enhanced snow events. Sorry, those are going to be kind of interchangeable terms here throughout the talk. But you need sufficient fetch, so the wind direction and the orientation of the lake must align. You're going to need a solid temperature difference between the water and air temperature, and you would like to see some moisture, of course. We can't deal with just a moisture-starved environment or anything like that. So we'll look into 2 events that occurred in late 2020 downwind of Lake Wheeler on the Tennessee River. All right, and there are a few kind of meteorological processes that can further enhance our vertical motion kind of downwind of lakes. You get thermally direct circulations, and they've been noted in the literature, several references there where you have thermally direct circulations that can increase the buoyancy, resulting in further intensifying any lake enhanced or lake effect snowband. Also looking at, my co-author also looked into, in 2016, looked into differential surface roughness over several bodies of water across the southeast, and Lake Wheeler was actually one of those. They showed how the slowing of winds as they encounter land will lead to additional low-level convergence. So something else that just continues to enhance vertical motion there as well. Another interesting factor that I didn't include here in this presentation, but would be interesting to look at further, is just the upslope flow that occurs downwind of the lake. I was just looking at a topographic map before this talk, and the average elevations along the lakeshore are about 600 feet, but you do get some mountains that rise to about 1,200 to maybe even 1,300 feet or so. So you're talking about a potential 600 to 700 foot rise there downwind of the lake. So you have some additional upslope flow as well. So for our different data and stuff we'll be looking at the high top radar. The TVA here has a nuclear plant that has water temperature data that we'll also look at. We'll look at the Decatur ASOS, and then we'll look at some RAP proximity model forecast soundings. And of course, since we're at the satellite webinar, we'll be looking at some satellite data as well. So here's just an image of Lake Wheeler. It's pretty, I think it's the second largest lake in Alabama, second behind Lake Gunnersville. This yellow line really doesn't represent the entire lake. The lake extends a little bit further to the east and west up here to the Wilson, or Lake Wilson, and then to the east you have Lake Gunnersville, but this is more shallow and narrow river. But you have a really broad fetch here for about 44 kilometers, as you can see, and the prime fetch angle is about 305 degrees. The yellow dot here is the Browns Ferry nuclear plant that we'll be using for water temperature data for this study. And here's the yellow dot for the Decatur airport that we'll be using for ASOS data and proximity, or actually be using proximity soundings from the Huntsville airport, which I should have labeled, which is right here. So not too far away, just on the northern sides of Lake Wheeler. Another interesting thing to note that didn't throw up an image of is Lake Wheeler is pretty shallow lake. The Tennessee River really broadens and gets fairly shallow here as we go into this large fetch. Look at some elevation maps of where like 30-foot water depths are pretty uncommon, and you know there are some depths down to 40, 50 feet or so. Those are even more rare. So a pretty shallow lake overall as the Tennessee River really broadens in this area. So we'll really just dive into the first event here. So the first event occurred in November 30th, which is a pretty early time of the year to get snow this far south. So November 30th, I would think even up in the Great Lakes, this is kind of prime lake effect snow season here. The lakes haven't frozen over. Of course, the Tennessee River is not really ever going to freeze over down this far south. But you can see, try to point out some landmarks a little bit better here. But Lake Wheeler is here. As you can see, my mouse kind of forms the county boundaries here between Limestone, Morgan, Lawrence counties. And that's where you have that kind of broadening out of the river. And then you can see this enhanced reflectivity across northern Morgan County, kind of downwind of the lake here. So really a pronounced band here. You don't see these reflectivity values really anywhere else across the whole kind of radar scope here in North Alabama. So a clear kind of enhancement there of low level moisture from the lake there. Looking at the visible satellite imagery, much longer loop. Sorry, I want to go back and kind of highlight that our main time here is really between 20 and 21Z where we see this enhancement. So I wanted to point that out as well. My satellite loops are a little bit longer, so but I do have a few still frames and some other things to point out here in the satellite imagery. So 20 to 21Z, this kind of talk about this over and over with some of these satellite loops. Unfortunately, it's right around sunset for this time of the year, so we're losing a lot of what we could look at here. On the visible satellite imagery, again, I'm not the best satellite expert, but you maybe can see some enhancement there and some cloud cover late right before sunset. But it's really subtle, not a whole lot there in the visible imagery. Look at the day cloud phase imagery, and you'll see a lot that are you'll see a lot of stuff that's kind of more this low level clouds with water droplets. So for my day cloud phase, this is kind of your key. You know, you want to look at your different colors and stuff like that. So we're really trying to find some greens or anything that goes more towards green here. And you can see just a touch of that here right at sunset coming off of Lake Wheeler here, highlighted here. You can see maybe just some very subtle hints of that towards the end. Sorry for the just complete, it goes completely to red there with sunset. But right there, maybe even again here right before sunset, you can see just a little bit of that glaciating cloud as we move more towards the 2 to maybe even some more toward the 3 color there, some more enhanced greens. But again, the moisture is so shallow in these situations, which I'll go over with a model sounding. So you're not going to get a whole lot of glaciation there, but maybe just a hint of some of that there. Which I have a few more satellite imagery loops that'll show a little bit better indication there. I want to thank Chris White, just one of the also works here at the Weather Service office, for putting this together for me. He was looking at these events with me as well, and he pointed out how well things showed up on the snow ice band. And you can definitely see this is a shorter loop. This is only from roughly about 1945 to 2115Z. So this is kind of in that key time frame where that radar reflectivity shows some clear enhancements. And here we're looking for these darker colors to indicate ice here. And you can definitely see it right there across northern Morgan County, and as it goes into Marshall County, just a clear enhancement, or clear ice there in the clouds from this snow ice band. Something you can see a lot better just with this single channel compared to the RGB that I showed earlier. Really kind of fascinating. We mentioned maybe trying to adjust some of the color scales to pull this out a little bit more, but I think even here, without doing that, it's pretty obvious that you have some ice in these clouds here. Here's just a still image of the RGB, right at 20Z. Sorry, the label over here is wrong, but right at 20Z. I tried to get this as soon as I could because, again, the sun setting really messes up a lot of these satellite images, unfortunately. But you maybe can see some different, more leaning toward the 2 color here. But again, it's just so hard to pick out with the sun setting and going down, as you see the RGB really lose that reflectiveness. Sorry, have a hard time with that word. And also wanted to look at the cloud top phase stuff to see if there was anything that we could glean from that. And unfortunately, not a whole lot that we can take away from this product in this case. You don't really see anything downwind of Lake Wheeler here. No kind of ice signal popping up or mixed phase signal popping up. So looking at a little bit of the meteorology for the event, just looking at the ASOS and stuff like that. So the Decatur ASOS is just to the north of Lake Wheeler, really on the northern shores of the lake here. Highlighted the times of the temperature and dew point. So the temperature was dropping. We had a really strong Arctic air mass for late November this far south. So you're seeing mid to upper 30s for temperatures, and then your dew points are in the mid to upper 20s. So pretty cold temperatures, above freezing though, but we did get some snow at the surface here. And when you look at the wind direction, remember, the one thing I want to refer back to is that the prime fetch angle is 305 degrees. So during this time, we're talking about wind direction of 300 to, or really sitting on 300 here for these observations that we have. So nearly matching, nearly identical to that prime fetch angle. When you look at wind speeds, the winds are blowing pretty good across the lake, varying from anywhere from about 11 to almost 20 miles per hour, 18 miles per hour. So really strong winds blowing across the lake at that prime fetch angle. So picking up that moisture there associated with the lake. We look at a proximity sounding from the Huntsville Airport. This is like a 0-hour RAP sounding here right at 20Z. So that's kind of our prime time that we saw that banding there. And you can see the moisture, these pink kind of dash lines, that's your dendritic growth zone. So that's like -12. So your moisture is extending up into those lower reaches of your dendritic growth zone. So you got moisture up to about -12 or so. So you do have just barely enough moisture to squeeze out some snowflakes and stuff like that. Your precipitable water values here is 0.56 centimeters, which are just, really, really low. But anyway, we do have a little bit of CAPE. There's 20 joules per kilogram as you have some decent lapse rates in the low levels, and you would think with moisture, kind of warm air there over the lake, you could even enhance those just a little bit and pull up your dew points here just a little bit to maybe get some better lapse rates over the lake as well. And when you look at your winds here in the lowest five kilometers or so, you really have that wind right there at that prime fetch angle up to about 800 millibars. So up to the top of that moisture, your winds are right along that prime fetch angle. So had a really good setup to observe what we had here, to observe that, or to create that lake enhanced snow band. So winds at KDCU, the Decatur ASOS, located just to the north of Lake Wheeler, were really just nearly identical to that prime fetch angle. I mentioned water temperature data. Sorry, haven't brought that up yet, but water temperature data obtained from Browns Ferry Nuclear Plant was nearly consistent. So from the surface to the bottom of the lake there, where they measure about 6 meters deep where they are, is pretty consistent, about 12.8 degrees Celsius there. And this created a temperature difference of 15 degrees C from the water temperature and air temperature. So pretty solid temperature difference there, and a 22.7 degrees C difference between the water temperature and the 850 temperature based off the proximity sounding there from the RAP. Moisture was limited to the lowest 800 millibars of the atmosphere, with precipitable water values that are really low, 0.56 centimeters. But there were amounts of half an inch to an inch of snow measured in the lake enhanced snow band. This is really, you may have to adjust your screen resolution for this. Sorry, the visible blue band the next day is really hard to pick out here, but kind of circling this area in eastern Morgan County and western Marshall County. You can see some white here with some snow on the ground. I probably should have thrown in a few images from social media where it's pretty obvious that they had about an inch of snow on the ground in places near ARAD. So, clear snowfall occurred here and is associated with this band without really any reports of snowfall anywhere else across northern Alabama. All right, so I'm starting to run out of time, so I'll kind of quickly cover this other event, not nearly as impressive, so it won't take quite as long. But this event occurred on Christmas Eve night into Christmas morning. Yes, here, some snowfall here, Christmas Eve and Christmas morning this far south. But it really wasn't all that impactful. You can see maybe a little bit of banding here downwind of Lake Wheeler across, again, eastern Morgan County, western Marshall County. You can see a little bit of enhancement here, not near as much. Again, there's kind of scattered light flurry activity everywhere. It's not like the last event where it's really kind of the only thing in town. There's a few more flurries and stuff, but it looks like there's some clear banding here moving off of the lake. Use the nighttime microphysics for this event since we are at night and sunset's not too much of a problem with this event. You maybe can see some stuff leaning towards a few of these colors, maybe towards 5 here at times downwind of Lake Wheeler that might indicate some mid-thick water ice clouds. But again, really subtle. I think an interesting feature here is in that the moisture is kind of on the lake enhanced snow band is kind of the southern end of the moisture extent here, especially right here as we go into this time frame more towards 3Z. That's kind of interesting that it contributes to kind of the southern end of the moisture. And you can see that a little bit better on the satellite imagery than you can see that on the radar imagery that we showed earlier. And there you can see that as well, right at 3Z. So kind of the southern end of those clouds, those ice clouds. So pretty interesting that just happens to coincide with that. Looked at the cloud top phase product, and there's a little bit more signal here for some ice in the clouds and stuff like that. But to be honest, this is a colder weather situation, as we'll see on the proximity sounding. So that could be one of the reasons why we get a little bit more signal in this, where we're just dealing with a slightly colder atmosphere. Of course, this is later into the season, so as we go into Christmas there. So looking at the Decatur ASOS again, like I said, a little bit colder situation. Our temperatures are down around freezing to slightly below freezing. Our dew points are a good bit lower, right in the mid-teens. And then our wind direction's a little bit more to the west here, so we're talking about wind directions to vary a little bit more from 290 up to like 310, 320. Our wind speeds are still fairly strong this day as we're dealing with the Arctic air mass sweeping into the region and really varying from about 10 miles per hour to all the way up to 20 miles per hour during this time frame. Looking at the RAP proximity sounding, way less moisture for this event, incredibly low moisture, talking about precipitable water values of only 0.3 of an inch, so really, really low moisture environment for this situation. As you can see, moisture really just, try to mention, hey, there's some moisture, but it's really, I'm trying to convince myself that there's something there, but there's really not a whole lot of moisture there. But maybe some there in the dendritic growth zone. Winds are a little bit more westerly, like I mentioned, so not nearly aligned with that prime fetch angle, and just no CAPE here. I know the last event is only 20 joules per kilogram. You're like, hey man, that's not much, but hey, at least there was something. And this event, there's really not much of anything. So again, winds at the Decatur ASOS reported directions from 280 to 310. So they seemed a little bit more, they were aligned with that fetch, but they seemed more variable than the last event. I know there were more observations for this event. I think we used the 5-minute observations for this event. Probably should have used those for the other one as well. Water temperatures obtained from Browns Ferry nuclear plant, they were nearly consistent again. Not sure. Again, maybe just the depth of the lake being so shallow leads to the water temperatures not being overly different from the top to the bottom of the lake layer, because it's pretty uniform in both cases. In this case, it was colder, of course, because we're later into the season, so we're down to 8.9 degrees C from the surface down to the bottom of the lake there, where they take measurements down to 6 meters. This created temperature difference of 10 degrees Celsius from the water temperature, and the air temperature, if you remember, the last case was 15 degrees Celsius. So really strong case there last time with the stronger moisture, stronger temperature difference, and just that kind of consistently aligned to the fetch there. So those three things that we talked about earlier that I covered on kind of the first or second slide, we really hit those pretty hard in the first event. And for this event, there were just trace amounts of snow. Again, just so little to almost zero moisture, really dry air mass that came in behind that. So both events clearly produced enhanced reflectivity and precipitation downwind of Lake Wheeler. Saw that in the radar and satellite imagery. The November 30th event, like I said, really kind of hit all those points a lot harder than the last event. So they're more low-level moisture was much better. The event also produced a greater temperature difference, as mentioned. For future work, we'd like to look into maybe developing a climatology for these events and work towards establishing more meteorological thresholds and variables that may be beneficial in predicting these events, and also like to look into convective allowing models anticipating and forecasting these events. I worked the midnight shift before the November 30th event, and I recall several of the convective allowing models, several of the CAMs actually did a really good job with this event by indicating that there would be some snowfall downwind of Lake Wheeler. So they really hit that event really well. So it'd be interesting to look into these a little bit more and see how well the CAMs do overall with these events. And again, as mentioned earlier, really like to look more into kind of some of the high resolution kind of elevation type stuff to see just exactly how the elevation changes and looks downwind of Lake Wheeler along that prime fetch angle, because just doing some kind of glances before this talk, just kind of thinking about that more, it sure looks like there's something there where there's some elevation differences of 500 to 600 feet from the lakeshore to where some of these lake-enhanced snow bands occur. So that would be interesting to look at as well. So I think that kind of concludes things here. I think that was a solid 20 to 22 minutes. So I think well within time, and welcome any questions here for the last 5 minutes or so.
Thank you, Matt. Great presentation. Any questions or comments from the audience? You can either speak up or go ahead and put them in the chat box or question box. Well, I'll have a question then. This is Dion Bicus, by the way. Did you have any DSS graphics, for example, to just let folks know about the possibility of a little more snow with these events, Matt?
Unfortunately, no. We kind of did in real time as this occurred. I mentioned in the AFD that morning of that it happened, but just maybe not understanding these events well enough didn't give me the confidence to kind of put something like that out there. But it was clearly in a couple of the cams that I looked at, and kind of realized that this was, the fetch angle really lined up with the winds we were expecting that day, and it was really a cold Arctic air mass that was moving into the area, and it's really early in the season, so I knew the lake was still pretty warm. So I did throw kind of a short paragraph about it in the AFD, but unfortunately the DSS for this event was kind of like near-term nowcasting type stuff.
Okay. I see a question from Joseph Patton. Has any lightning been observed with these events by the GLM or ground-based networks?
Not that we've observed. We had ironically, I covered 2 of these, but we had a couple more in February. So we haven't observed that with any of these events just yet. I'm not sure if it's just because it's just so shallow, like the proximity sounding showed. Cape, there was some Cape there, but it's really limited. So those could be some factors for why we haven't seen anything like that. And the rates even in that November 30th event, which I think is probably about as good as we could get, or a really high-end event for something like this, weren't incredibly impressive, with only kind of half an inch to an inch over probably a 3 to 4 hour period of lake enhanced snow. So those are kind of some factors that really limited any potential for lightning or anything like that.
Okay. Any other questions or comments?
Yeah, this is Scott. Maybe this will work. You mentioned it was impactful. So were there like more traffic accidents for this first event where there's an inch of snow down deep in the south, or was it melting as it fell, sort of?
Yeah, I think some of the fact that the first event was right, or in the mid 30s and stuff, really limited some of those impacts. But yeah, it was just one of those situations. Like as soon as those kind of moderate intensities are over, it really starts to melt and stuff down here, especially with the ground still being fairly warm, with it being late November and stuff like that. So we didn't really hear of any like major traffic accidents or anything like that. The main town that would have been impacted there was Arab, which is in western Marshall County, but don't recall hearing of any kind of major accidents or anything like that.
Thanks.
Okay, last chance. Any questions or comments? Okay, at this point, we want to thank Matt for this great presentation. I'll post it onto our visit web pages in a little bit in case you want to forward this along to anybody that was not able to attend.